Okay, so your bonding continuum. Okay, so this is an important part and it comes in a lot to your bonding and structure part of the course. Okay, so we need to remember that ionic bonding is a transfer of electrons, whereas covalent bonding is a shared pair of electrons. Okay, so the greater the difference in electron negativity, they are less likely to share electrons. So instead of share, they're going to transfer. Okay, so the bigger the difference in electron negativity, the more likely they're going to be ionic, or an ionic bond is going to be formed. Okay, so we're on to our bonding continuum. You can see this in the PowerPoint also. Okay, so you've got your different types of bonding that you've just learned about. So you've got your pure covalent bonding, you've got, or your non-polar bonding, you've got your polar covalent bonding, and you've got your ionic bonding. Okay, so as you come across, you're increasing a ionic character, which means you're increasing the chance that the atoms are going to transfer electrons as opposed to share. Okay, so remember our pure covalent bond, we've got H2 here, they are shared equally. Okay, we've got your polar bond, remember this is also non-polar. Don't worry about it if you just see it as pure. Okay, you've got P and Cl. Chlorine has a higher electron negativity value, so it pulls the electrons closer to itself, causing itself to be partially negatively charged. Okay, so this side is delta negative, which means this side has to be delta positive. Okay, and you've got your ionic. I've not put a bond here because you don't share the electrons, they are transferred. Okay, so lithium becomes a positive ion, it's transferring its electrons to the fluorine, which gives it a negative ion. Okay, so now I'm going to tell you how we can determine, depending on electron negativity values, what type of bond is present or what type of bond is going to be made. Okay, so if the difference is less than 0.5, you're going to have a non-polar or pure covalent bond. So the difference between the two electron negativity values, if it's less than 0.5, not including 0.5, it needs to be less than, it's going to be non-polar. Okay, from 0.5 to 1.4, okay, which is quite a big difference here. So if the difference between the two atoms, difference in electron negativity between the two atoms is within this range, you're going to have a polar covalent bond. If the difference between the two atoms is more than or equal to, so 1.5 and over, if the difference is equal to that, you're going to have an ionic bond. Okay, so an example of how to do this. Right, so you've got your HCl. Okay, your H, if I move this round, is 2.2. Your Cl is 3.0. Okay, so your electrons are going to be pulled toward this side. Your difference is going to be 0.8. Okay, so your difference is 0.8. Is it going to be pure covalent? Is it less than 0.5? Nope. It's going to be in this part. So it's going to be polar covalent. Okay. So HCl, C is 2.5, H is 2.2. Okay. Your difference here is 0.3. So is 0.3 less than 0.5? Yes, it is, which means your bond is going to be pure covalent or non-polar. Okay, that's one you need to know. Your C to H is going to be non-polar. Right, so your Li to F. So you've got lithium, which is 1.0, and your F is 4. So your difference is 3 is 3, what category does 3 fit into? It is more than or equal to 1.5. Okay, so it's going to be ionic. Okay, and your last one then is boron and hydrogen. So your boron is 2.0 and your hydrogen is 2.2. Your difference is 0.2. Where does that slot in? Which means it slots into your non-polar or pure covalent, which means, because as it's 0.2 and it's less than 0.5, so this one's going to be non-polar. Okay, again, if you want me to do any more examples or want me to describe it in any different way, let me know and I can put another video